Right triangle trigonometry. Brief history. The Babylonians could measure angles and are believed to have invented the division of the circle into 360 degrees. However, it was the Greeks who are seen as the original pioneers of trigonometry. A Greek mathematician, Euclid, who lived around 300 BC, was an important figure in geometry and trigonometry. He is most renowned for Euclid's Elements, a very careful study in proving more complex geometric properties from simpler principles. Although there is some doubt about the originality of the concepts contained within Elements. They they are influential in how we think about proof and geometry today. Indeed, it has been said that the elements have exercised an influence upon the human mind greater than that of any other work except the Bible. The Pythagorean theorem. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. The Pythagorean theorem is named after the Greek mathematician Pythagoras, who by tradition is credited with its discovery and proof, although it is often argued that knowledge of the theorem predates him. There is much evidence that Babylonian mathematicians understood the formula. Right triangle trigonometric definitions. All triangles are taken to exist in the Euclidean plane so that the inside angle of each triangle sum to pi radians or 180 degree. Therefore, for a right triangle, the two non-right angles are between 0 and pi over 2 radians. Solving right triangle. We begin our investigation of the trigonometric functions using right triangles, since the two acute angles in a right triangle are restricted to degree measures between 0 degree and 90 degree. We cover only those angles here. In this triangle side, A is opposite angle and big letter A, and side B is a adjacent angle. So this is our opposite angle. A is the opposite angle of A, big letter A, and side B. Oh, where's the B? So we have B, 3B. Is adjacent angle. A. So wait. Side C is the hypotenuse. This. Six possible ratios can be formed by selecting two of the three sides of a right triangle and forming a fraction made from the lengths of those sides. Two triangles are similar. If the ratio of corresponding sides in the two triangles are equal, this means that the two have the same shape or one is a scaled version of the other. Similar triangles contain the same angles, although their sides lengths may differ. So, this is the name, the ratio, and the notion. And the sine of A is the opposite opposite over hypotenuse. So, we write sine of A is equal to, our opposite is A over hypotenuse. Our hypotenuse is here. And the cosine of A is equal to adjacent This is the adjacent. So, here's the B. B din na siya. Over hypotenuse. So, if we write cos A is equal to B over C. In a tangent of A, so we have opposite over adjacent. So, tan A, so we have A over B. Cotangent of A is adjacent over opposite. So, adjacent B over A. In secant of A, hypotenuse over adjacent. So, you have sec A C over B. Cosecant of A is equal to hypotenuse over opposite. So, we write cosecant A is equal to C over A.